Welcome back to the shop, everyone. This week's video takes place in 2026, week 17. That is going to be April 20th to April 26th, and we are getting back to doing a little bit of engine work here. So we are going to check piston to valve clearance. So this is absolutely critical. If your valve kisses your piston, you can kiss your engine goodbye. You're going to bend the valve, potentially break the tip off, and then destroy rods and pistons, and that's just not good. So I've got some modeling clay here. What I'm going to do is I'm going to press it nice and deep down into the pockets of the piston, get it all nice and tight, and then I'm going to put the head on. So I'm going to fully torque the head. So as I was putting this on before, I put all the full lubricant on the threads. So I use the ARP assembly lube on the threads, under the washers on the nuts. And I get this all properly torqued up to, I want to say it's 110 foot-pounds in 3 equal steps. So I think I did like 36, 72, 110, something like that. And the reason why you need the heads fully and properly torqued is if they are not fully properly torqued, you may, when it is fully torqued, you may actually lose some more distance, and if you're not accounting for that loss of distance, you could run into a bad situation. With the head all torqued down, now I need to install my rocker stands. So on these heads, there are 8 bolt holes for mounting the rocker stands. 4 of those bolt holes or stud stands, or no, I guess they're bolts. 4 of those bolt holes go into the intake runner on the head. So what happens is, if you were not to use thread sealant, so I'm going to use thread sealant, but if you were to not use thread sealant on these threads, you would potentially get oil in your intake, and then you're going to be smoking, and that's not a good time. So the 4 holes that go into your intake passage, you absolutely must use thread sealant. Now, all of my head studs, those are all blind holes. Those do not go into water jackets. If this was a regular 302 block, you would absolutely need to use thread sealant on some of your head studs. So yeah, fortunately for me, don't have that problem. All of the dart block head stud holes are all blind, so no worries there. So I'm just reading the instructions to figure out the torque and figure out what we're going to use. And so we're going to be using thread sealer on 4 of those holes. I'm just cleaning up the shaft rocker stand because, you know, I had it on the head once before when I was checking for push rod length. So now that I have all that figured out, I'm going to install the 4 bolts with the thread sealer, and then the other 4 bolts will just get oil on the threads per the instructions. And the reason why I'm using the thread sealer now is this is going to be a permanent install. I'm not planning on pulling these shaft rocker stands back off again, so might as well install them, torque them, and do all of that stuff now. Alright, so it is time to start figuring out piston to valve clearance. So to do that, what I'm going to do is I'm going to install a couple of push rods now that I finally got them. I will install them into the lifters. I will put the shaft rockers on, and then I will set lash. Now, the way to set lash is it's EOIC. When the exhaust is opening, you lash the intake. When the intake is closing, you lash the exhaust. That makes sure that your lifters and the is at the base of the camshaft circle. By doing the intake opening, by doing the exhaust opening and lashing the intake. That makes sure that the intake is on the base circle of the cam, and vice versa. By doing the exhaust when the intake is closing, you guarantee that the exhaust is on the base circle of the cam. Alright, so at this point what I'm doing is I'm setting lash on the push rod and the rocker. So I've got my adjuster tool. I'm adjusting the adjuster in and out so that I have just enough lash between the rocker roller and the push rod. Sorry, the valve tip. And so my cam says they want a 10 hot lash, which usually is going to equate to about a 4 cold. As things heat up, the lash is going to grow. So what I've done is I think I actually set it up to 10 cold for this, which is totally fine. That 4 to 6,000 really isn't going to affect anything. So now that I have lash set, I am just rolling the motor over a few times so that the valves are cycling and imprinting into that modeling clay. So now that that's done, I can unadjust all of the valves. I do that with it on its base circle. I don't loosen the valves when it's in tension. I mean, I don't know if it would hurt anything, but I'm just going to make it so that there's no tension on it when I do the unlashing of it. I just think it's better for it, probably. So yeah, with that all done, I'm going to pull the shaft rockers off. I'm going to pull the push rods out, and then I'm going to pull the head off. So when I pull the head off, I'm going to pull the head stud nuts off in the same order as I put them on, and at roughly the same amount of tension. That way, you're not removing all of the torque off of it at once and kind of bananaing it. At least that's the way I look at it. They have you torque it up in 3 stages. I might as well untorque it in 2 to 3 stages. All right, let's just get this head off. Now that the head is off, I'm going to take a razor blade, and I'm going to very carefully, because I don't want to cut into the piston, but I'm going to kind of just press the blade into the putty and into the depression, and just see how much putty there is between where the imprint of the piston or the valve was and the piston. And I've got like 240,000, something like that. I got tons of clearance. So what that tells me is I actually need a bigger camshaft to push those pistons down a little bit more. But yeah, so tons of clearance, tons of piston to valve clearance. It's what I figured. I didn't think this was going to be a problematic combo, but it's always best to double check, because if you don't double check, and as I've said, if the piston hits the valve, you're going to have a real bad day. So it's free to check things. Might as well check them. Otherwise, you might be paying to replace parts, and paying to replace parts is not fun. Now, if piston and valve clearance wasn't good, what could I have done? Depending on how close it was, potentially a thicker head gaskets. But ultimately, it would probably be different pistons. Could potentially do a shorter rocker so it doesn't push down as far, potentially. I don't really know. I'm not an engine builder. I'm this engine's builder, so I don't have really that experience or that answer to say what you could really do. But from my limited experience, potentially different rocker ratio, a little bit shorter rocker ratio, so it's not pushing down as far, or a different piston, or at least modifying these pistons to adjust the valve reliefs. Don't know. I'm just glad it worked out. So with that, I'm just going to go ahead and fully install both of these heads. I see no reason for the heads to come off anymore. So yeah, we're just going to get these installed. with both heads installed, I'm just going to go ahead and install the what is that, passenger, no, that's gonna be the driver side rocker mount. Put sealer on the 4 bolts the same as I did the other side, and then just oil on the others. So install this the same way I did the other side. Right, now that we have the heads installed, it is time to start installing the oil pump. So a little while back, when I was just kind of mocking some stuff up, I figured out that I need to clearance the oil pump. So what I'm doing is I'm installing the oil pump studs. I'm using some retaining compound on them because I'm not pulling them out again, and putting the pump loosely on just to make sure that I have the initial placement for where I'm going to start removing some material from the pump to clear all the counterweights and everything. And yep, I've got all of that kind of sorted. So the idea is I'll put the pump on, I'll put a nut on so it's kind of tight, and then I will go over to my bench in the far corner. I'll put a bag back over the engine so no metal stuff gets in the air and comes and lands on the engine. Go over to my bench in the far corner. I'll knock a bit of material out with a carbide burr, and I'll come back over, test fit, check, all that stuff. Of course, I tape off all of the holes in the oil pump so that I'm not getting metal particles in the oil pump, because that would also be very bad to have metal pieces in there and send that through the engine. And so what I do is I take an initial chunk out, and then I realize I need to take more out of kind of the base. So what I do is I take my blue Machinist's Dicom. There's a little bottle on the bench, right kind of in the middle of the bench. Got some blue on the side. I'll take that. I will paint some on the bottom of it. I'll bolt the oil pump down, and then what I'll do is I'll take some TIG rod, bend it in such a way that I can mark the bottom of the oil pump with the TIG rod through the machinist die. That way I know exactly where I need to grind on the oil pump to clear the block. So this is a iterative process. I do it a little bit at a time. So take a little chunk off, go back, retest, refit, come back, take a chunk out, test, fit, all that until I'm happy with the clearance. The reason being, I'd rather take less out and fit it more than take too much out, because you can't add it back. I mean, technically it's metal, you could weld more, but for all intents and purposes, I'm going on the plan, you can't add more. So just sneak up on it, be very diligent in the work that I'm doing, and just come back and forth a few times until I'm happy with how much clearance I have. Now that I'm happy with how much clearance I have, I need to take the tape off the oil pump, and that tape may have a little bit of metal shards in it. So that's why I'm putting the paper towel underneath it, is to hopefully catch anything that comes out of the tape. I just don't want anything going through the engine. And the next thing I gotta do is figure out the oil pickup. Now, on my old engine, I had a one of the bolts for the main caps had a stud on it for the oil pickup tube, and as you can see on this dart block, there's no stud for the oil pickup. So this block, you can run a dry sump, but obviously I'm running a wet sump, so I don't have the stud for that main cap. So that's a bit of a big deal and kind of gonna slow things down. I'm gonna have to go and do some research and figure some of that stuff out. So yeah, why was I just rolling everything over? I don't remember. But I did. Oh, I dropped the oil pickup bolt into the engine. So when I was trying to put the oil pickup tube on, I dropped the bolt into the engine. So yeah, having a random bolt in your engine would be catastrophic. So I had to flip it around for it to drop out. Otherwise, I would have been unbolting the bottom end and heads would have come off, and that would have sucked. So fortunately, I did not have to do that. But yeah, so just getting a general fitting of the oil pump or the oil pickup versus the oil pan. So you see I put a straight edge across the oil pan just to figure out where I need to mount the oil pickup tube and what distance, because you want a quarter to a half inch off of the bottom of the pan so they can suck up all the oil without having any restriction. So that was the day before. I talked to somebody who is far more intelligent than I am. He's probably forgotten more about building engines than I'll ever know in my life. And he said, just modify the head stud. Just weld a stud to it. He said, what I do is I round off a 3/8 bolt, and then I just weld it to the top of the main stud or main bolt. So that's what I'm going to do. I modified a little piece of aluminum so that I could clamp down this 3/8 bolts that I've rounded the head off to the head stud. And then what I'm going to do is I'm just going to tack it on like 3 sides or 2 sides, and then I'm just going to fully weld all the way around. It's one of those things where I'm always very hesitant to do stuff like this, just because this is my first time doing something like this, and it's nerve-wracking. I'm not gonna lie. Like, it's not like, oh, just doodaloo, I'm just gonna modify a head stud. Like, that's the head stud. That's like one of the main components of the engine. If that head stud breaks or lets loose, I'm potentially going to destroy my engine. So I did the welds quick. I believe I did them efficiently. The welds looked good. I wasn't too hot. I didn't heat up the bolt too much. And what I did is I brought my thermal gun over just to check how much heat I put in the bolt. And when I was done welding the bolt, the shank part of the bolt that goes into the block was like 450 degrees Fahrenheit. And that bolt at 450 degrees is not going to change its metallurgic properties. The engine itself is going to live around 200, 220. So being at 450 briefly is not going to hurt anything. I don't believe I don't believe I affected the integrity of that bolt in any way, shape, or form. I think it's going to be totally fine. And so, yeah, once I weld this on, put it back on, and then we can continue putting the pickup tube on. So with the newly modified head bolts, or not head bolt, I don't know why I keep thinking head bolt, main bolt, I gotta modify this pickup tube. So it's not properly lined up, and the pickup itself is a little too close to the bottom of the pan. Like it's effectively touching the bottom of the pan, which is not good. It's not going to pick up the oil like it's supposed to. So I got to go over to the bench. I'm trying to just, you know, move the pickup tube a little bit. It's pretty solid. It's not really wanting to work. So what I end up doing is I'm like, okay, I can just bend the tab that it mounts to. So I start bending it. I was like, okay, that kind of works. But now the whole tube is angled. So I'm like, okay, now I flatten out that tube. So it's got like 245s to make it flat. You know, one side's higher than the other on the pickup. So just double checking. And so we're just going to take a bit of time, make this work, make it straight, make it so the pickup tube bolts in happily. As you'll see, this takes a few trips from the bench and back. And then I even eventually, once I get the pickup tube mounted in the car, I just kind of bend it while it's on the engine. Probably not the best thing for it, but, you know, it worked. I'm very happy with how it's all turned out. And I didn't have to cut anything, didn't have to weld anything. It just by bending it a little bit, it's all working pretty nicely. So with that all happy, there are gaskets that were supplied with the oil pump. So I'm just going to put all the gaskets on, and then I'm going to Loctite the bolts on the pickup and on the pickup, and then tighten them. Okay, with the oil pump installed, I'm going to go ahead and I'm going to start installing the oil pan. So my oil pan calls for the 4-piece gasket. Yes, you can get the 1-piece. I had it before on the old one. It was okay. I don't know if it really leaked because I never actually properly sealed the crank, as well as I never properly lubed the rear main when I installed it, so it's possible I burnt out the rear main. But there was definitely a leak in the back, and that may have been due to the 1-piece gasket. So I'm going to go ahead, do the 4-piece gasket now. Making sure I'm putting some sealant in the corners where the 4 pieces line up. I found out these gaskets are side to side. So one side of the rail is different than the other, so you got to make sure you get them on the right side. I also had to modify the gasket a little tiny bit because one of the main caps was just in the way. So I was just cut it out, get it lined up, no big deal. So we'll get that in place. And then trying to get these front and rear seals on the timing cover and the main cap was a bit of a pain in the ass. They didn't want to go and squeeze down into the areas provided. So I actually end up cutting them down just a little bit. I don't think it's a big deal. I don't think it's going to hurt anything. I think everything's still going to seal just fine. Especially with that little bit of sealer in there. But if I got a massive leak, well, I'll know that I fucked up. So yeah, so I'm just going to go ahead, get that done, and then install all the bolts, torque all the bolts. Now, if you are an actual engine builder, you may have caught that I completely fucked up and missed something. So all that work I just did is all coming back apart. You know why that is? And that's because I forgot to install the oil pump drive shaft. Now, the oil pump drive shaft is this tiny little thing that goes on the input of the drive shaft. It goes through the block, and then the distributor actually connects to it. So the way that works is the cam gear, as the engine is spinning, the cam gear spins the distributor, and as the distributor spins, the bottom of that goes into the oil pump drive shaft. Through that oil pump drive shaft, it connects into the oil pump, and that's how the oil pump works. Well, I forgot that one little piece. I had it on the bench, but as you can see, my bench is a mess, so I had all these parts and pieces out, and it didn't click at the moment. I was just putting like the second or third to last bolt in, whatever it was, and I was like, oh, I forgot it. So I got to take it all back apart, put that in, put it all back apart. So I got, oil pan off, oil pickup tube off, oil pump itself off, and then put the drive shaft in. So don't forget to put your oil pump drive shaft in. Anyways, learning experience. Well, it's funny because I forgot the oil pump drive shaft in my old engine as well. But I was able to get it. I was able to work it. So I didn't learn. So learn from my mistake. Don't forget your oil pump drive shaft, or else you're going to redo a ton of work. So with the oil pan on, the engine flipped back over, I'm just kind of taping everything off because I don't want dirt or dust to get into anything. With the heads on, getting the garbage bag on is a little bit tougher. And also, I'm kind of getting ready for this to go in the car. So there's a few things I got to get ready before this goes in the car. One of the things is the engine plates. And I hadn't painted these before. I was considering just leaving them aluminum, but I changed my mind. So I'm cleaning them up. I'm using some acetone to clean them all up. And then I'm going to paint these black. I'm not going to put any metal flake in the black just because time constraints and whatnot. And I'm just spray painting these. Ideally, at some point in time in the future, I would love to pull this all back off and properly paint this the same as the body. But for now, just a quick spray job is all I got time for. So I kind of do the dumbest thing here. I just set these up without any kind of stands or anything on this box. At the moment, it kind of works. Fell over. Seems to be better, like 90 degrees like this. So paint them. But what I eventually do is I move the box into the sun to get them to dry a little bit quicker. And when I do that, they fall. They get a bunch of the dried off paint in them. It's just kind of a dumb thing to do. But what it taught me is, hey, make a stand out of just some TIG rod, and you'll be better off. So yeah, what you saw me just do is I knocked the dowel pin out of the old block, and that dowel pin is what aligns the bell housing. So this is a new block, but the old bell housing. So what I need to do is I need to check run out on the bell housing compared to the block. So what I'm going to do is I'm going to pull the dowel pins out of the old block because I don't have new ones, put the dowel pins into the new block, and I will then check run out on the new block, or on the bell housing on the block. With the two dowel pins installed, what I'm going to do is I'm actually going to remove the last of the parts from the old engine. So what I need from here is I need the oil pressure sensor. So I'm just going to quickly move the oil pressure sensor over. I don't actually need that big long tube because the dart block kind of puts the oil pressure sensor in that almost exact same spot anyways. So obviously the dart block's a little bit better than the old one. And then I'm going to cover this engine. At some point in time, I actually robbed the valve covers off of the old engine. Obviously, I'm not doing it here for some reason. But, hey, it is what it is. Going back over to the new block, I'm going to get this ready to get the engine off the stand. So what I need to do is I need to figure out which bolt holes go in the front or go into the block. So some of the bolts are 7/16, some are 3/8. And since these heads are the exact same, the way the bolt is on the back of the block is the way the opposite one is on the front, if that makes any sense. But yeah, so that's my engine leveler right there. I use that when I'm putting the engine in the car, and I have these plates that just bolt into the back, and then it's attached by chain to the leveler. Well, in the past, I've kind of maxed out my engine hoist a few times because, you know, the engine hoist has like 5 links before it gets to the leveler, and then the leveler has like all of that meat plus like 5 links. So I'm actually going to pull the leveler off, and I'm going to pull 2 links out of all 4 corners to shorten this up a fair amount. So I'll cover the engine, go over to the other end of the shop where my vise is, and get this leveler modified and cut down. Alrighty, so with the leveler modified, I got some cardboard on top of the valley, just because the tape was not really strong enough to handle the leveler. So put a little bit of cardboard down there just to protect everything. I don't want that leveler hitting any of the lifters or anything like that. So yeah, cardboard protects everything. That's why I got a stack of it in the shop. That, and I'm kind of lazy and just haven't gotten it out to recycling yet. But that's besides the point. So we'll throw that back on there and we'll get this thing ready to come off of the stand. So before I continue on with any of that, there is something that I need to get done this weekend, which is installing window trim clips. So I was going to have my windshield installed, but the installer was like, well, slow your roll, buddy. You don't have any of these trim clips installed, and trying to install these once the windshield is in is going to be nearly impossible for you. So we're going to hold off, and I'll come back once you have ensured that you do have these clips installed. So that's what I'm going to go ahead and do. For the carbon roof, I need to drill some holes and then screw the clips in there. So I'm going to drill the holes. I'm going to use some of the sealant to seal the holes, and then some tiny little screws just to hold them in. I think that should be sufficient. Panel bond might have been better, but I also didn't want it to be 100% permanent, at least with the right stuff. The gasket sealer, once it dries, it'll be rubberized, but I could, in theory, remove it fairly easily. I think the panel bond, if I used that, it would, like, these clips would be permanent, period, end of story. So anyways, that's what I'm doing as a little aside, because I need to get this done. So yeah. So I might have a bit of ADHD just because I didn't finish all the window trim clips. But this is like the next day, I think it is, like the next morning. And I'm like, you know what? I'm going to start by cleaning off the bell housing because I didn't finish the window clips. But that's okay. We're going to clean off the bell housing. With the bell housing clean, I'm going to rob the last parts off this engine. So I'm going to grab the valve covers off of this. I think that's actually the last part that I need to grab off of this, is just the valve covers. Because, yeah, the rest of the engine is going to stay together, and I'm going to put this into a different car. Of course, I'll have to buy valve covers for it. I'll have to buy an intake. I'll have to buy some things for it, but that's not really a big deal. Yeah, this time I want to protect all of the ports, at least the oil ports. I don't want any water condensation getting into the intake or exhaust, or getting into the intake ports. So that's why I'm putting all the paper towel in the intake ports. And yeah, pull the valve covers off, and then we'll throw this back in the bag, and I'll actually throw this back into storage. With all of the parts robbed off the last engine, the bell housing ready to go, let's get that engine off of the stand. So the engine's pretty high up right now, so I'm just going to drop this down a tiny little bit while I'm moving it around. I've seen some horror stories with people moving them with them way up. The center of gravity is way high, and then the whole stand just like rolls backwards and flips, and not a good time. So you can see I got that tire there. So I'm going to try putting the engine down on the tire, but the tire is just too flimsy. It bends a lot. And I was like, you know what, this isn't a good idea. So I end up just switching out and putting some wood under it. So the rear of the oil pan is super flat. I got no issues, and the front is as well. So I got no issues just laying this down on wood. But the front, where the rear sump is, there's the bolt for the front sump, and the wood was hitting it. I couldn't really get the wood at a good angle. So what I'm going to do is take a chunk of wood just over to the other side of the shop, and with a drill bit, just put a big hole in the very front of the wood, so that the oil pan drain plug can just sit in a little hole in the wood, and then that's perfect. So now that I have the engine on the ground, it is time to index the bell housing. Now, you've seen me do this before. I did it on the old engine. Quickly clean off the flywheel here. Indexing the bell housing. What this involves is putting the flywheel on the engine, putting the bell housing on the engine, and then I'm going to get a dial indicator with a magnetic base onto, and I'm just going to attach it inside the bell housing. I have an indexing plate. So the indexing plate gives me a full 360 degree that my dial indicator can run up against, and I'm going to check the I'm going to put the dial indicator on the magnetic base, set it at 0, and then I'm going to take measurements at every 90 degrees, so 90, 180, 270, and 0. Actually, first I'm pounding in the pilot bearing. I didn't think I was going to get another chance to do this, so I'm just hitting the new Ford Racing pilot bearing in, and then I'll torque the bell housing on and check its indexing. And I am very fortunate that this bell housing, or this block out of the gate, the bell housing and the block out of the gate are just like almost dead center. Don't have to do anything, so I'm very happy about that. If I had to modify the dowels or get offset dowels and adjust it, I would have been probably delayed a week or two. So we're totally cool here, though. So I'm just gonna go through the process. At this point in time, I'm putting that plate on. I've got it upside down because I'm an idiot. So anyways, we'll put it on the right way. Once I get that block of wood out of the way, we'll put it on the right way, and then put the flywheel on. And because I'm a bit of an idiot, I'm kind of putting the flywheel on without realizing I still have plugs to install in the rear of the block. So as I mentioned before, when they make this block, they have a big bar that bores from the front all the way through the rear. And so they ship plugs with the block to, block that off. Otherwise, you'll have no oil pressure and oil will just gush out the back of the block. So I'm installing the flywheel. These only go on one way. And the way they do that is the pattern of the flywheel bolts is not symmetrical. It's actually asymmetric, I guess would be the word, where the bolts aren't exactly spaced out the same. So if you're ever trying to install a small block Ford flywheel and it's just not going on, the bolt holes aren't lining up, just spin the flywheel and then it should eventually line up. I'm of course looking in my book of instructions for torque specs and all that stuff. And yeah, so after I got this tightened, I was like, should I Loctite these bolts? And then that's when I remember, no, I got the cam plugs to do still, so it's all gonna have to come back off anyways. So we just torque this up, tighten it up, make it so it's even. That way when I'm running my dial indicator, you know, everything's as true as possible. Yeah, so I'm just going to go through and index the bell housing, and then I will take it off, put the cam plugs in, and then we'll just reinstall everything with the clutch. trying to be a little bit smart here. As I said, the flywheel is indexed to the crank and it only goes on one way. So I'm just putting a little yellow mark to match the bolts. That way if I ever have to pull it off again, I can. And these are those 3 little cam plugs I was telling you about. So there's O-ring, but I'm going to Loctite these in. I absolutely do not want these backing out under any circumstances. So a little bit of Loctite is going to help me keep those in there. And then with that, we can reinstall that plate, reinstall the flywheel, reinstall the I guess not reinstall, install the clutch, and then install the bell housing. So next up, right here in my hand, this is my mid plate. So this is just supposed to help keep, the engine and transmission and everything solidly in the car. I believe that's a 1/4 inch aluminum. I have had to modify it for the old headers. But I'm deciding to paint this just like I did the front engine plates. So I'm going to paint this black the same. So first I got to clean it all off. I get all the old tape off of it, and then I can clean it off and we'll paint it black. So as you can see, mid plate goes on, and then I put all the bell housing to engine plate bolts on. Now, technically, I believe the mid plate is actually supposed to go between the bell housing and the engine, but that just didn't make a lot of sense to me. It would have left a gap between the bottom of the bell housing and the SFI plate, which wouldn't be good. It's supposed to gets bolted together. So I just put it on the outside and kind of went, I hope that's good enough. Alrighty, now this is time for an exciting moment. It's time to get the engine in the car. To do that, I need to unbolt the leveler from the front of both heads, put those engine plates on, and then we can start getting this in the car. Not much to say. I'm going to put some moving blankets around the front frame rails to protect them as I'm installing it. I'll put some cardboard on the frame rails to hopefully protect everything from getting scratched. Mid plates in. I am going to have to drill some holes in the engine plate tabs that I welded to the front end. I will have to drill holes into the mid plate tabs that I welded onto the car. Yeah, enjoy the show as we get this engine mounted in this car. I'll tell you, that engine sitting in there, it looks so freaking pretty. I can't wait till I have the rest of it done and in there. Now that I have the engine in, it's finally time to getting back to installing these window clips. I got distracted. I just wanted the engine in the car, but I really need to get these done because the window guy is supposed to be coming on the weekend. So I just got to get these done. The original location for this wasn't working, so what I ended up having to do is pull it back out, beat out one of the studs, and then the kit comes with rivets, so drill it out, put a rivet in there, and do the same thing on the driver's side, and then finish putting in the rest of the trim clips on the driver's side A-pillar there. Alrighty, so now it is time for something a little bit fun, but also a little bit daunting. Time to start figuring out the header install. So these heads have what's called a raised exhaust port. So it's 0.375, that's 3/8 of an inch higher than stock. The port spacing is also different. So the headers that I had before just will not work. So I decided I'm going to buy a header kit because, you know, I bought headers that are supposed to work with the steering shaft and all that stuff. I had to modify them. So I figured if I'm spending a pile of money, I might as well buy a custom header kit. I'll build custom headers for this. That way I can put the tubes exactly where I need them, and, you know, stuff like that. So that's what we're going to go ahead and do. So I've got the exhaust gasket on. I've got the flange on. I'm just putting the header bolts in. I'm not fully tightening them down. They don't have to be super tight for this. There's going to be some movement that has to happen in the flange and in the pipes. And then what am I going to do next? I'm going to be a little bit intelligent here. At least I think I'm going to be a little intelligent. And what I'm going to do is I'm going to put the spark plugs in. I'm going to put the oil dipstick tube in. So that way, as I'm building the headers, I make sure I have enough room to get a socket in to get the spark plugs out. Because if you don't have the spark plugs in and you just build a set of headers and you're not thinking about it, if you turn down too tight and you can't get a socket onto the spark plug, you're really screwing yourself. Because you're going to have a bitch of a time changing spark plugs, or maybe you just can't, or you're going to have a hell of a time getting spark plugs on the spark plug, or like getting the plugs themselves getting the spark plug wires onto the spark plugs. And definitely don't want to do that. Want to make sure it's nice and easy. So just taking a look at all that stuff, I'm kind of looking underneath as to where I'm going to place the collector, stuff like that. And yeah, so I'm going to get into the dipstick tube now. So I bought this flexible dipstick tube, but again, with the old headers, it was just in the way and didn't work. So what what I'm doing now is pulling out the big plug in the rear, the oil pan sump, but that's not the actual plug that my oil dipstick tube uses. I actually use the one that's just kind of in front of it at an angle. So since I've got that out and I realized I got the wrong one, I'll just put some sealant on it eventually, put it back in, and we'll use the correct location for the dipstick tube. So if we take a look at this dipstick tube as I just kind of loosely thread it in, it's super duper long. There's a lot of excess dipstick tube, and I really don't need as much length as it has. Obviously this is just a universal dipstick. So I'm kind of like thinking, oh, can I put this here? Can I put this here? But it's like, well, that'll kind of get in the way of the headers, and that's not good. So I eventually just end up choosing to cut the length of the tube down. It's just honestly, it's just PTFE line. It's nothing special. So what I'll do is I'll go over to the bench. Well, I'm going to mark it first where I want to cut it roughly. Then I'll go over to the bench and I will treat it just like I do PTFE line. I'll use my big cutters. I'll cut it, and then I'll just move the fitting up. And honestly, it actually works pretty good. I'm really happy with how it all turned out. So yeah, I'll cut this down, move that fitting up a little bit, and then we'll put it back in the car. So if you look at this as I put the dipstick tube in, it is hilariously long, obviously, because I just cut a bunch out of it. But there's no point in cutting it down until I actually have the 7 quarts in the oil pan. Once I have the 7 quarts in the oil pan, then I will cut the dipstick tube down, mark where the full line is, and that way I have a proper full line. But hey, until then, I got the dipstick tube done. It's cut down. We can start planning out these headers a little bit better. All right, well, folks, with getting the dipstick tube in, getting that plug back into the oil sump, and just kind of covering the engine here, that is all the time that we have for this week. So as always, if you stuck around this long, I'd like to thank you for viewing, and we'll see you in the next one.